to treat. So one way of recognizing that the basalis is within the endometrium is to check whether you are seeing enough of this endometrium that has the endometrial lining. Okay, if you've got nice endometrial lining in much of your curated material, then you don't have to worry about it. But the other thing that I want you to sort of note is that there is a difference. There is a difference between the basal glands, that is the glands of the basalis, and the functionalis. Number one, the basalis does not respond to the hormones estrogen and progesterone. Well, of course they do, in the sense that where else does the endometrium regenerate from? It's all obviously regenerating from the basalis, but recruitment of receptors. Every target organ of a hormone has to recruit receptors if that required effect of the hormone is going to take place. And receptors are very, very important in any target organ. And there's a lot of work that goes on about why, when there is, everything else seems to be normal, there is good estrogen, there is good ovulation, there's everything, and still the endometrium does not respond the way that it should. And there are, sort of diseases, or let's not call them diseases, but there are abnormalities in receptor recruitment in the endometrium, which has got nothing to do with the hormones that are circulating in the peripheral blood. But just notice that these have got some very odd looking shapes, they do, and they are dark in their the nuclei are dark, and they appear dark because there is not much cytoplasm. Okay, so I know that sometimes people mistake this for a proliferative phase endometrium. Okay, but it's probably not a proliferative phase endometrium. And when you see only basalis, and you see, and we will see this as we go along, you see basalis, and close to the basalis you see the endometrial lining epithelium, then you are looking at a post-menopausal atrophic endometrium. Okay, there is no space, there is no functionalis, between the basalis and the lining epithelium. Okay, so I think that message we have to get across. So now let's come to endometrial physiology. And physiological endometrium can be pre-pubertal, but we hardly ever see pre-pubertal endometrium. Yes, you agree, Priya, that we don't see pre-pubertal endometrium?
Yes, ma'am.
Why is that? Why don't we see pre-pubertal endometrium, Priya? What do you think is the reason that we as pathologists don't get to see pre-pubertal endometrium? Any thoughts on that, Priya? Mansi, why don't we see pre-pubertal endometrium? Aishwarya?
In pre-pubertal stages, the corpus is not yet well developed. The cervix remains a major part.
I see. So the cervix is our hindrance to getting some samples of a pre-pubertal endometrium. Okay. Not what you look at. Any reason that you can think of? Yeah. Okay, we'll leave that to later. It's common sense, right?
Most of them are related to menstrual disturbances, ma'am.
Yes, I mean, why would anybody sample a pre-pubertal endometrium? Okay, for one thing, most pre-pubertal girls have not had sexual intercourse, and we're not wanting to do that. And we just had, and what if somebody's bleeding from a pre-pubertal endometrium? Okay, the cause is very unlikely to be in the endometrium, right? Okay. Where do you think the cause is likely to be? Come on, let's ask the third years now. Bhavna?
Can be external genitalia bleeding, ma'am, from vaginal bleeding.
Oh, sorry, where is this bleeding coming from, Ananya?
The cervix or external genital tract now.
I'm telling you that she's bleeding from the endometrium. Why would a pre-pubertal girl be bleeding? She's 6 years old. She's 5 years old. I mean, if she's 8 or 9 nowadays, puberty starts at 8 or 9 or whatever. But in any case, there is this girl now. She's 8 or 9 or 6 or 5, and she is bleeding from the endometrium. First of all, she's bleeding, and there is nothing and we can't see her cervix anyway, because we're not going to do a vaginal examination on such a woman. Sorry, she's not a woman yet. She's a girl. So
could be some
coagulopathy, and she bleeds from an endometrium. And when she hasn't yet started cycling, well, you know that she may have some ovarian or other issues, right? And she may be having follicles that are developing early, or she may have some kind of endocrine problem which is affecting the ovaries, and this endometrium is responding to estrogen, which is being produced somewhere or the other. Okay, and this is seen in pediatric endocrinology, where these girls, maybe 4 years old, 5 years old, 6 years old, have an endocrine issue of various kinds, and there is estrogen circulating, okay, and they bleed from this endometrium. Okay, good, fine. So you don't, and today, how would you know that she's bleeding from this endometrium? And I think Dr. Bhupesh Goyal has given you the tool. He told you, you don't have to actually sample an endometrium to know what is going on, right? If you want to find out whether this young girl has got a hypoplastic endometrium, or for some reason this endometrium is thick, it must be because there is an endocrine problem and she's got estrogen circulating, and you can see the thickness of the endometrium. You can also examine the ovaries. You can look at so many other organs, including the adrenal glands, and you will figure out what the problem is and from where that bleeding is coming from. So for God's sakes, all of you, pre-pubertal endometrium is not to be sampled. Okay, it is not sampled. You can do a whole lot of stuff without sampling a pre-pubertal. I have never seen, even in the days when we never had ultrasound, a pre-pubertal endometrium, unless that the uterus came out for some other reason, in which case then we saw a pre-pubertal endometrium. Very good. So we don't see that physiological endometrium at all, but we do see cycling physiological endometrium, which is either ovulatory or anovulatory. And once again, you have to understand that just because you cycle, it doesn't mean that your cycles are ovulatory. Okay, every now and then, certainly at menarche and very certainly around menopause, perimenopausal, many of the cycles that a woman experiences is anovulatory. Okay, once the whole ovulatory mechanism has settled in, and that's because your pituitary, the GnRH, the pituitary, and so the ovaries, etc., have now got in concert with one another, then ovulation becomes more or less established. But every now and then, women do have an ovulatory cycle, and you will never know, because it doesn't always mean that you go to 30 days and 40 days and all that just with an anovulatory cycle. Okay, then of course you have the pregnancy associated changes that you see, which are very physiological. Okay, and then an endometrium after menopause is very much a physiologic type of endometrium. Okay, good. And let's do a little bit about the menstrual cycle, because I feel that people are very confused about the menstrual cycle. And I know gynecologists are aware of this, but it always amazes me that in a class you have a lot of females and you have some males, all right? But the females themselves don't understand their own physiology. And I think it's high time that we take an interest in what's happening to our own physiology. And I guess the males should be interested in what's happening to their reproductive physiology as well. Now, in the top line over here, you see the ovum, the egg, yeah? And then you see these little stromal cells, which we call the granulosa cells, which are forming, are layered around this follicle. And you start to see that there is what is called an antrum, or a space that develops. And we call that the follicular space. And that develops, and finally you have ovulation, then you have the corpus hemorrhagicum, you have the corpus luteum. And the difference between the stromal cells that are around this, what's the difference that you would notice around this developing? Because they're all stromal cells, they're specialized stromal cells, which we call, what do we call those specialized stromal cells? Ananya? We call it the sex cord stroma, right? Okay, good. So what are those stromal cells that are developing around the follicle? Ananya?
Yes, ma'am.
Tell me. What do we call those stromal cells? Ananya, can you hear me, or have we lost you? We lost Ananya. Okay.
Ananya is there. Ananya, can you hear us?
Sir, it's not audible.
Can you hear us, Ananya? No, she said it's not audible. All right, let's ask Bhavna.
So the
Bhavna?
granulosa cells, ma'am.
Granulosa cells. So all the way up to ovulation, what is seen around the follicle? Bhavna?
Granulosa cells, ma'am.
Granulosa cells. All right, let's ask Mansi. Mansi, do you think that you have only granulosa cells around the follicle, or is it something else as well? Bhavna may be right, but what do you think?
We see granulosa cells as theca, interna, theca externa.
That's absolutely right. So it isn't just the granulosa cells. You also see a theca interna and a theca externa. Okay, and these are all sex cord stromal cells. The granulosa cells are most discernible. Okay, I'm not going to take a class on what the ovary looks like, but they are the most discernible cells, and we'll see some of those cells a little later. But outside them, because they have a nice cuboidal sort of shape, and they're very blue. Why? Because there's not much cytoplasm. And then as you get to the theca interna, the cells become more spindly, and they begin to collect some fat in them. And then the theca externa are even more spindly, and they contain a lot of fat. So what actually is happening is that as you see estrogen in the system, okay, and this estrogen is coming from where, Bhavna?
Ma'am,
Where
granulosa
is
cells are
it?
secreting the estrogen into
What
the
is it?
stimulus of FSH.
Yes, so it's the granulosa cells. In fact, it is the sex cord cells. No, it's not just the granulosa cells. It is also the theca cells, etc. The more luteinized they get, the more estrogen they are secreting until FSH, until luteinizing hormone comes into the picture and progesterone comes into circulation. Okay, so under the effect of follicle stimulating hormone, that's FSH. Okay, you see the follicle stimulating hormone which falls and then rises in the follicular phase, and the estrogen is rising along with it, and you see a little peak of the follicular phase epithelium. Follicular phase. FSH, that is follicle stimulating hormone, okay, and you get an LH peak. When that estrogen reaches a certain point, okay, there is release of the luteinizing hormone, which promotes ovulation, okay, and ovulation occurs, and then you get a collapse of that follicle, and that theca externa and interna start to collect a lot of fat, because progesterone is, is one of the hormones which is made from cholesterol, so it becomes very yellow, and that's the corpus luteum. And the corpus luteum has a finite life unless it is supported. And if it is supported by early pregnancy, by beta HCG, which makes its own estrogens, and the corpus luteum will die. Yeah, and then you get both estrogen and progesterone levels fall, and then you get menstruation. Okay, what is menstruation, Aishwarya?
Shedding of these endometrial cells.
Shedding of the endometrial cells. Okay, why does the endometrium shed?
These
Why does the endometrium shed? I know it sounds like a stupid question, but why does the endometrium shed?
these corpus luteal cells which are not supported because of pregnancy are not to be shed off because they don't have any
Okay,
function.
very good. But why should the endometrium shed?
Because these worn out corpus luteal cells which become albinous don't have any more use. This no.
So it endometrium sheds because the corpus luteum dies. Is that what you're saying?
Yes, and it becomes very hyperproliferative after the effect of progesterone. It just sheds. So.
Oh, it just sheds. Okay. Anybody else would like to say why the endometrium sheds? Why does anything shed? For that?
May I?
Yes, of course, Bhupesh.
Yeah, this is probably the last time that I'll be putting in. After that, I have to go.
No. Please tell them why the endometrium sheds.
So, friends, what you need to understand is, as Dr. Borges has brought out, that corpus luteum has got a finite lifetime of 11 to 12 days. And if it is not rescued by the beta HCG secreted by the early pregnancy chorionic villi, then it dies after 11 to 12 days. Once it dies, the corpus luteum function was to produce both estrogen as well as progesterone. And those estrogen and progesterone were going to stabilize the endometrium. And once it dies, there's a withdrawal of hormones. So it's the withdrawal of both estrogen and progesterone that actually gives rise to, constriction in the spiral arterioles of the endometrium, and that causes ischemic damage to the functional layer of the endometrium, leading it to shed as menstrual efflow. So it's the withdrawal of hormones, and that's why when the hormones are withdrawn, the FSH and LH start rising again to stimulate the follicles in the next cycle. So that's how it works. I hope I've explained that.
Absolutely, Bhupesh. And there is a mechanism for why an endometrium sheds. Yeah, it obviously sheds because there is no support now. Okay, and what do we mean by support? You require a healthy hormonal milieu in which both estrogen, and please note that there is a lot of estrogen in the post-ovulatory phase. It's not as if that estrogen has disappeared. There is also progesterone in that post-ovulatory phase. And when that corpus luteum dies, because where is that estrogen coming from? It's coming, as Dr. Bhupesh very rightly said, from that corpus luteum, because of the granulosa cells, etc. They have just metamorphosed or into the theca, which is the yellow part, but they are secreting estrogen and progesterone. Both estrogen and progesterone are hormones that are produced from the precursor, which is cholesterol. That's why, and the progesterone is even more requires a lot of cholesterol to get converted into progesterone through the androstenedione pathway. All right, so now you have corpus luteum and it dies, and when it dies, because it's no longer supported, all the hormones, and they fall precipitously. Can you see over there how precipitously these hormones have fallen? And as a result of which, the endometrium is no longer supported. You have those spiral arterioles, which we will see, which are there in the post-ovulatory endometrium, which we call the secretory phase, so to speak. Now, the spiral arterioles are being supported. In fact, they are actually initiated by progesterone. It's very much part of the progesterone pathway. So the spiral arterioles are no longer being supported because the progesterone is gone. They kind of shrivel up or they contract, and there are two purposes to those spiral arterioles. Okay, one is of course to produce ischemic shedding of that endometrium, but at the same time to make certain that endometrium doesn't bleed forever. Because can you imagine if you didn't have the muscular arteries, because the muscular wall of these arterioles which contract, okay, you can bleed and bleed and bleed. And now think about when somebody or any woman is bleeding from a non-progestationalized endometrium, how much that endometrium, if it is shedding, can bleed, because there is no spiral arteriole with its muscular wall to stop the bleeding because the muscular wall will contract. Yes, it will produce ischemia, but it will also stop devastating hemorrhage from the endometrium, and this has to happen cycle after cycle. Okay, so I think sometimes we have to think about how wonderful nature is. But there is something that I've written down here. Estrogen promotes proliferation, and please remember that. Okay, remember it almost like a mantra. Estrogen promotes proliferation, and progesterone promotes differentiation. Yeah. And this is important. So what does proliferation mean? We'll see in a minute. And what does differentiation mean? We will see in a minute. Okay, so let's ask them a little question over here. Since we were talking about ova and eggs and all that sort of thing, anyone of you wants to take this? Ruta, what is the egg or the ovum in a prepubertal ovary? What do we call it? Do we call it an oogonium, like a spermatogonium? Or do we call it an oocyte, like a spermatocyte? The equivalent in the testis. What do you think it is? I mean, this is just
Ma'am, it is a oogonium.
It's an oogonium, all right? So that's what Ruta thinks. All right. Ria?
It's an oocyte.
It's an oocyte. All right. Now, who agrees with either Ria or Ruta? Bhavna, you agree with Ruta or Ria?
Oocyte, ma'am.
Oocyte. Mansi?
Oogonium.
Oogonium. All right. We've got some interesting. Ananya?
Oocyte, ma'am.
Oocyte. And what about our friend from Nigeria? What do you think?
He's left, Anita, he's left.
Oh, he's left. Okay. All right. Well, the answer is, I don't know, maybe some people are answering in the chat box. Lena, or Bhagyashree, if you can see. But the answer is oocyte. Okay. There are no oogonia. Yes,
Can I
please.
just clarify?
Yes, please, Bhupesh.
So, just once and for all, the oogonia are in existence only till 20 weeks of intrauterine life, after which they enter mitosis. After which they enter meiosis. So up to 20 weeks, the proliferation in the oogonia is happening by mitosis, and we reach the largest number of, I think, 7 million at about 20 weeks of intrauterine life, and thereafter they enter meiosis, and the proliferation stops thereafter. And there is an attrition in the number of these oocytes. We call them the primordial follicles containing the primary oocytes. So they continue to dwindle down in number, and by the time a girl child is born, from 7 million, they have already reduced to 1 to 2 million. And the number continues to reduce till they go into puberty, by which time it's only 400,000 left. And out of which, about 400 undergo ovulation in a lifetime of a woman. So that's how it goes. So I just thought that it will be...
No, you're absolutely right. And I think it's very important that there are no oogonia. Like there is a spermatogonia, which you see in the testes. You don't see oogonia, and because oogonia are undergoing their stem cells, which undergo mitosis until, as was rightly pointed out, at some time, 20 weeks of gestation, the oogonia are now entering into meiosis, and this is a very interesting, sort of phase. Of course, I'm not going to go into it now because it's not part of my talk. But you have meiosis in which you have extrusion of polar bodies. Okay, and you have two polar bodies. That means they are small, scrunched up oocytes which are not going to develop into ova, or to have no potential to develop into ova, and they just get extruded and they fall off. And the second polar body happens somewhere around puberty as the ova starts to develop, and it's quite possible that some at least a lot of people feel, and all of this we have found out now from the IVF guys, how the development of this oocyte is actually taking place, because you can culture them now in vitro. Okay, so now in connection with that, since we're talking about the menstrual cycle, the menstrual cycles end at menopause. Okay, so now let me ask anybody, whoever wants to answer. Ananya, why does menopause occur? You can choose any one of these options. Number one is age over 45. The FSH levels drop, as a result of which you don't have any estrogen, etc., and that's it. Okay, oocyte numbers are finite, and the ovarian capsule gets too thick for ovulation to occur. So come on, Ruta. If you were paying attention to Dr. Bhupesh, the answer is very obvious.
Oocyte numbers are finite.
Yes, the oocyte numbers are finite. Okay, if the oocyte numbers are finite, no matter how much FSH you have in the system, okay, there is no development of a follicle. Therefore, there is no estrogen. Therefore, there is no stimulation of the endometrium, and you have menopause. If there is no stimulation of the endometrium, and you have a stable level of estrogen and progesterone with minor variations which are not enough to do anything, then you get menopause. Okay, and all this is so well orchestrated. And I think that humans are the only apes. That we are apes. I hope you know that we are apes. Okay, and you know what an ape is? It's not the same thing as monkey. Anybody wants to tell me what is an ape? And you can write it in the chat box if you want to. Bhavna, what are apes? How do you define an ape? Huh? You know what an ape is? It's a tailless simian. That means we are, for all practical, monkeys without tails. Okay, so whenever you think of the apes, and think of all the apes that you know, like the gorillas and the chimpanzees and us, we don't have tails, no? We have the remnant, which is the coccyx over there. So we are the only ape, by the way, that has menopause. Okay, there is no menopause in chimpanzees, there is no menopause in gorillas, there is no menopause in orangutans. Orangutan, that orange-looking ape that you see in Indonesia, well, they also don't have menopause, but we do. So we are a very unusual kind of animal. We are animals and we are apes, and I don't think that we should look down on our cousins. They are very much there. All right, so now, and here this is exactly what Dr. Bhupesh was saying, that you have oogonia here in the fetal ovary up to the age of gestational age of around 20. Then you have oocytes in which meiosis is taking place, and the same the number of oocytes keeps on decreasing until, as you're born with some million oocytes, of course, when in the neonatal ovary, they keep on sort of disappearing, and they leave little scars in the ovary, and you get the developing follicle. And we must also remember that just not one follicle develops in each cycle, several follicles develop in each cycle, but in one follicle outstrips the rest. Now that's another big story which I don't want to go into over here. It's all about recruitment of receptors, etc. Why only one follicle develops each cycle, unless you happen to be from certain parts of the world, like in Scandinavia, or in certain families where twinning is common and where the twins are alike. So they are not one boy, one girl, or they look different or whatever. When you get twinning in which two follicles can be produced. Okay, so that happens in Scandinavia. Now here is what I was going to tell you about. Okay, here's the cortex of the ovary, and you see the follicles that are developing, and you have the medulla. When you look to see what the follicles are like, you have the granulosa cells, which are very distinct, and then you see the theca interna. Yes, over here. So I think whoever talked about the theca interna is absolutely right. And this is a really well-developed reproductive type ovary follicle in which you get the zona granulosa. You see this little oocyte with its zona pellucida, which is the little capsule that surrounds that, which looks very hyalinized, and then the granulosa cells that are immediately surrounding the ovum is called the corona radiata. The fluid is present in the space which is called the antrum, and this fluid is full of estrogen. Okay, so that's part of it, and this just tells you the number of follicles, how there is a sharp decrease from the time of birth right up to menopause. Okay, and when all the oocytes are finished, there are no granulosa cells that are surrounding those oocytes, as a result of which there can be no developing follicles, no matter how much FSH you pour into the system, and that is menopause. All right, so once again, just remember this: estrogen promotes proliferation, because now we are going to the endometrium. Okay, right, and we come now to what we call the proliferative phase endometrium. Okay, now I just want one of you to answer, why is it called the proliferative phase? Aishwarya?
It's under the effect of estrogen, it proliferates, and there's a lot of growth.
All right, now how do you know it is proliferating, Aishwarya?
Because the glands per se have this pseudostratification, and there is mitosis. There's
Yes.
overall cellularity is more.
Overall cellularity is more. All right, does everybody agree with Aishwarya, Mansi? Why do we call it the proliferative phase? She's right, that under the effect of estrogen, there is proliferation. We've said that, that estrogen promotes proliferation. But how do we know that something is in the proliferative phase? When I look at it, I should know. So how do I know that?
Ma'am, in the proliferative phase, there is proliferation of both the glands as well as the stromal component.
Okay.
So in the glands, we see that the glands are tubular, and there is stratification along with mitosis, and there is increase in the stromal cells. So these cells are basophilic with less cytoplasm.
All right, let me ask Ananya, what is the most significant thing that both of them have said? There's only one significant thing that they have said.
Mitosis is present both in the glands
Mitosis.
and in stroma.
Absolutely, Ananya. All right. Whenever we talk about proliferation, whether it is in the endometrium or anywhere else, okay, the only way we can know that something is proliferating is if you see mitosis. Okay. Oh, you can do lots of other things. You can go and do immunohistochemistry, and you can look for proliferation markers, labeling indices, etc. But most of the time, what are we dealing with? We are dealing with an H&E section. Okay. And the only way that we will know that something is proliferating is if we look for mitosis. Very good. So now here is the proliferative phase, and you can see all this stratification, pseudostratification, stroma, gland to stromal ratio, all sorts of things, tubular glands, anything you may say, it is all part, yes, of the whole picture. But there is one outstanding thing that you should be looking for, and that is proliferation. Okay, and you can see the mitosis. You don't have to look far. And I just want to ask each of you, how often have you looked for mitosis in an endometrium? Be honest.
So, ma'am, to categorize the phase of the this endometrium, we look for all these features like nuclear stratification, mitosis, these well-spaced tubular glands, stromal mitosis.
So then you are one of the very few people who do it. But I recommend that you do it, okay? Because there's only one thing, as I told you, that defines proliferation. And if you want to make the distinction, which is becoming increasingly irrelevant, if you want to make this distinction between a proliferative phase and a secretory phase, you will have to look for mitosis. As I said, it's becoming irrelevant anymore, okay? And if you want to see how it looks, that's a mid one that has been done on an endometrium, and just look at the glands, look at the stroma. It's a huge labeling. So the labeling index is high in the proliferative phase. All right, and here we have the secretory phase. Okay, and you heard Dr. Bhupesh talk about how he was able to date the endometrium correctly because there was subnuclear vacuolation. And when we ask students, how do you recognize the secretory phase? Okay, people will tell you there are corkscrew glands, and then there are secretions and so forth. Yeah, but one of the first things that defines the secretory endometrium is that there are no mitoses. Okay, so remember, estrogen promotes proliferation and progesterone promotes differentiation. And what is this differentiation in the endometrium? What is the function of the endometrium towards which this whole endometrial cycle is heading? It's heading towards what? Any one of you?
For the uterus for implantation.
Yes,
the uterus for implantation.
correct. So you need to have a bed for implantation. So the fully developed or the fully differentiated endometrium in every cycle must have secretions. You will have this spiral arteriole. Okay, and the spiral arteriole is there for two reasons, as we've said. Okay, to produce ischemia and to prevent excessive bleeding if there is no implantation and that corpus luteum is no longer supported. Okay, But you can recognize that this is a secretory endometrium if you have a well-developed spiral arteriole, and you can see it here on the bottom left-hand corner, and you see varying amounts of secretion within the and as I said, this is dating of this endometrium, that this is the 16th day, and this is the 18th day, and this is the 20th day, and all. You can forget about it because it is not relevant. It's only a question of you understanding how this physiology takes place. And if you want to see what the labeling index is, the big one labeling index, you can see the clear contrast with what we saw during the proliferative phase. Okay, so estrogen promotes proliferation and progesterone promotes differentiation, and this is a differentiated endometrium, well differentiated with the secretory phase secretions. That's why it's called the secretory phase, and of course the spiral arterioles. Okay, now what is this? Anybody? Aishwarya, I've got two pictures over here. Yes, so now tell me, what would you say about this endometrium?
The one on the left shows decidualization.
One on the left shows decidualization. Okay, what do you mean by decidualization?
This change in the cellular characters with increased cytoplasm, which initially starts around the arterioles and then subepithelial cells.
Sorry, what happens in decidualization? You get what? You can see I have a view over here. Yes, it is decidua. So what is decidualization? You can see it. All right, anybody else?
Increase in the glycogen content of the cells.
Increase in the glycogen content of what? Of what?
Stromal
Stromal
cells.
Stromal cells. You think that if you stain this with PAS, it would stain brightly and then it would be digested? Oh, you think that there is glycogen that is collected over there? You may be right. Okay, but what do you get? You get, it's kind of differentiation, yes, in which the spindly stromal cells have now become very large. Yeah, they have a box-like cytoplasm. Yeah, sometimes you can't see the cytoplasmic edges, but where you can see them, they are box-like, and the nuclei have become round, which is not what you expect to see, right? In the other parts of you don't expect to see that in the proliferative phase or in the early secretory phase. But as this progresses towards the late secretory phase, you get decidualization. Now, what's happening on the right-hand side? Is that any different?
Ma'am, the stroma is decidualized, but the glands are appearing atrophic.
They're appearing atrophic. Okay. What do you mean by atrophic?
They're lined by an attenuated epithelium, which is
attenuated epithelium. So what does that mean? What does it mean?
that it's not proliferating.
It's not proliferating. It's not proliferating on the left side as well, no? Are those glands proliferating? I don't think so. Okay. It's not proliferating. Neither glands are proliferating, but the decidua on both sides is markedly decidualized. Okay. Now, it just so happens that we know that this is true decidua because it's taken from a uterus that has a decidualization in a person who has been pregnant. And on this side, we call it pseudodecidua because there was no pregnancy associated with this. But can you really tell true decidua from pseudodecidua? Yes or no?
no.
Answer. I mean, I'm showing it to you. There's no proliferation either. Okay. So I don't think that you can tell one from the other. You just need to know the circumstances in that are present in this particular thing. Okay. But now we have answered this question. But anyway, let's see. Ruta, answer this quickly. Decidua is derived from what? Endometrial glands, stroma, pericytes, trophoblast, or potential trophoblast? Decidua is derived from?
Trophoblast, ma'am.
From trophoblast. Okay. Ruta, you want to say? Sorry, that was
sorry, ma'am. Endometrial stroma.
Yes, it is not. It is a maternal part of the endometrium, and we see decidua in a pregnant uterus. We see decidua, compressed decidua in an early placenta, but that is the maternal component of the early placenta. Decidua more or less disappears in very late placentae, but that's what decidua is. It is endometrial stroma. Okay, so let's answer this question then. What does decidua express? A1, A3, which is a cytokeratin. Does it express SMA? Does it express EMA? Does it express vimentin? You have to pick one of these things. Priya?
SMA.
You think it expresses SMA? Okay. Ananya?
Vimentin.
Vimentin. Okay. Would you like to tell Mansi why it does not express SMA? Why? You were a bit tentative about the vimentin, but you said vimentin and she said SMA. So now explain to her why it is vimentin and not SMA. No? Aishwarya?
SMA cells is smooth muscle origin.
No, I can't hear you. Aishwarya, a little louder.
Ma'am, SMA is for cells with smooth muscle origin. All these stroma
So what
cells.
is the endometrial stroma? Does it express SMA? No, it doesn't. The endometrial stroma by and large does not express SMA. Okay, so if you had to pick from this, it would be vimentin because it's unlikely. It is a stromal thing, so it's not going to express cytokeratin or, for that matter, EMA. And so therefore, the likely answer in this case is vimentin. And you see this. This is well-developed decidua. You see it. It's huge. It's boxy. The cells are huge. It is box-like. Okay, and often you see some lymphocytes and NK cells that are in this decidua. They're there in all placentae. They're in all decidua, and this is vimentin. And you see the vimentin very strongly expressed over there. And you shouldn't get cytokeratin or EMA or SMA. Very good. All right. Now this is menstrual phase endometrium. Yeah, and I don't think that you have any issues with this. That these are all glands that are broken up. There is a lot of hemorrhage over here. But even in the menstrual phase endometrium, please notice that you see an endometrial lining. Okay, so there will be fragments in a menstrual endometrium that will show endometrial lining. It is next to impossible to see the basalis shedding. It does not shed. That's the layer from which the regeneration or proliferation of the endometrium happens during menstruation. In the postmenstrual period. Now there are pregnancy-associated changes. You see what is down in the bottom left-hand corner. It can look pretty ugly, some of these, because there is nuclear variation. There's anisonucleosis, and you start to see sometimes very pycnotic-looking nuclei in these cells, in the endometrial glands. And this is what is known as The famous area stella. Yeah, yes. And the residua that you see on the right hand side. Excellent. Now here is non-cycling atrophic postmenopausal endometrium. You see the endometrial lining, and next to the endometrial lining there is a very thin endometrium in which you see the basalis, which are these dark-looking things, and you see some blood vessels. There is really no functionalis, right? And this is sometimes you get cystic change within the basalis of this endometrium, and then you call it cystic atrophy of the endometrium. All right, now we come to endometrial sampling. You heard all of the remarks that Dr. Bhupesh made, and I think those remarks are very, very pertinent. Okay, he talked about office procedures and he talked about non-office procedures. Now, the first thing which you call a suction biopsy or a Pipel biopsy is done in a gynecologist's office, and it's done without cervical dilatation. Okay, and therefore, if you are doing something without dilating the cervix, you will get a very limited sample of the endometrium, and that is superficial endometrial lining, which is a part of the functionalis. You cannot get anything else in this, and you will see a nice lining epithelium. Excellent. Then you have curettage, and we call it the DNC. That's dilatation and curettage, because you cannot enter through the cervix into the endometrium unless with a big curette without the cervix being dilated, and the cervix you cannot dilate a woman's cervix without the patient being under anesthesia. Okay, it is an OR, meaning it's an operating room procedure under anesthesia of some kind. You can either give short general, or people often give paracervical blocks or whatever. Some anesthesia has to be given, otherwise you won't be able to dilate the cervix. And what should that endometrium contain? It contains superficial endometrium and functionalis. It should not contain the basalis. This is, as I told you in the beginning, the purpose of looking for fragments without the superficial endometrium. All right, and then now we get quite invasive transcervical resections. It's an operating room procedure done under anesthesia. It is not performed, and you can understand why, if fertility is to be maintained. People can do hysteroscopies, okay? People often do hysteroscopies in patients who are premenopausal, who have very thickened endometrium, but it's done because you want to see what is happening in the endometrium, but you do not do a transcervical resection in patients who are wanting to retain their fertility. It's often done before a planned hysterectomy for dysfunctional uterine bleeding or fibroids. And what does it contain? It contains the superficial lining, it contains the functionalis, it contains the basalis, as well as portions of the superficial myometrium. So this gives you the full thickness of the endometrium and a portion of the myometrium, right? Okay. So what is very important before you start looking, or maybe while you're looking at an endometrial curettage or a biopsy or a transcure thing, is to know the indications. Okay, and most of the indications are these: abnormal uterine bleeding during reproductive life and postmenopausal bleeding. Most of the others are not quite often done. The USG findings of a thickened endometrium or polyp on a routine scan, or somebody's very unlikely to happen, they're usually bleeding. Okay, and then of course, if you have a missed abortion or bleeding after evacuation of products of conception, then yes, you will have some of these. Evaluating the effects of hormonal or other treatments, say a patient has is being progestationalized by giving external progesterone, then you may want to know whether that endometrium has reverted or not reverted from a unopposed estrogen type of endometrium. Then maybe you will do some kind of endometrial sampling with a Pipel. That means it's an office procedure, and to see whether or not that endometrium has got iatrogenically progestationalized. You do not do this for endometrial dating. And the important history that you must have, and very few gynecologists give you this history. They give you the age yet, yes, but they don't give you the height and weight from which you can calculate the BMR. You must know the menstrual status. You must know the menstrual history. When was the last menstrual period? And of course, the USG findings, any hormonal treatment, and other relevant history like diabetes, hypertension, and diet. And this is not just a list that I put up over here to complete my talk. This is extremely important. And if you don't do this, you often write some very ridiculous reports. You don't know that patient is menopausal, and you call that endometrium a proliferative phase endometrium. It's ridiculous, because you can't have a phase in a patient who has been menopausal for 3 or 4 years. So there's some reason why that looks like a proliferative phase endometrium, and that reason has to be ascertained. Why is this postmenopausal woman got an endometrium that looks like a premenopausal proliferative phase endometrium? But to write proliferative phase endometrium in a menopausal woman is a very ridiculous type of report. So you should know whether the patient is menstruating, cycling, or menopausal. All right. Now, on the right hand side, you have what is a classical TCR. Okay, you see a portion of the myometrium, you see the entire endometrium from the functionalis right up to the basalis, and it's got a nice endometrial lining. Okay, so you must look for adequacy, the phase, if it is cycling and it is benign. Once again, the endometrium, you only talk of the phase if it is cycling. You have abnormalities. You look for abnormalities in a reproductive endometrium, as Dr. Bhupesh said. That's happening less and less these days. Abnormalities in an atrophic endometrium, which may be polyps, or as we'll see, what else can happen. Iatrogenic changes, of course, we have to look for malignant change, or what we call atypical change. And we'll see some of these examples. All right? Let's look at endometrial proliferations. And now most of the gynecologists have changed from DUB to AUB. And AUB1 is about symptoms, AUB2 is about causes. And this is now something that they accept. So you may see this in some of your requisition forms. There are 4 causes of AUB that are actually present in the endometrium, okay, which you can actually discern when you see either the endometrium or the hysterectomy: polyp, adenomyosis, leiomyoma, malignancy, and hyperplasia. So that is PALM. But there are others which you're not going to be able to see in the endometrium at all. One is coagulopathy. The other is ovarian dysfunction. That's you don't know whether there is ovarian dysfunction or not. There are endometrial causes, like I said, receptor-related causes, which you're not going to be able to discern, unless you have a lot of history which will help you to make some diagnosis. Then there are iatrogenic causes, some of which you will be able to determine, and there is something called not as classified. So this is known as the palm coin way of approaching dysfunctional uterine bleeding. This coin, there's an E that is in that's endometrial. All right, now we come to endometrial proliferations, and the first is unopposed estrogen. Okay, We used to call it disordered proliferation. I still call it disordered proliferation because it's not a normal proliferation as you see in a normal cycling proliferative phase. You see that the shapes of these glands are irregular. Some of them may be cystic, as you see over here. But when you look at this endometrium, you'll see that it is proliferating, and we know that it is proliferating because you have mitoses in these glands. All right. So once again, I will emphasize again and again. Please note that there is the endometrial lining. Okay, so just because you see some star-shaped or branching glands, this is not the basalis. In most of these, you will start to see that there is an endometrial lining. Okay, and of course, it can be atypical hyperplasia, and with unopposed estrogen, you can get well-differentiated endometrial carcinoma because a lot of the unopposed estrogen, particularly in the post-menopausal group, just makes that endometrium very susceptible to exaggerated proliferation and endometrial carcinoma. Okay, now here you see 4 pictures. Okay, the top 2 is again unopposed estrogen. Yeah, there's unopposed estrogen over here, and this unopposed estrogen is like what you saw in the previous slides. Okay, it's just a high power, in fact, of one of the slides that you see in that. And here, with this continual proliferation of the endometrium, okay, you will get finally back-to-back glands and exaggerated stratification and mitoses and foci of these in an otherwise estrogenized endometrium. You can see this estrogenized endometrium over there is, I don't know whether this is truly estrogenized. It is estrogenized, but it is not a cycling endometrium. This is the basalis that you see, because you can see the basalis here in between. This is what is called atypical hyperplasia or endometrial intraepithelial neoplasia. Okay, so these are the effects of unopposed estrogen activity. Now, what do we mean by unopposed estrogen? Ananya, do you understand what is unopposed estrogen, or can you explain it?
In anovulatory cycle cycle, there will be no
It's
progesterone.
anovulatory. All right. So according to you, Ananya, it means anovulatory. All right. There will be
increased exposure to the estrogen, ma'am. So the glands will be proliferating.
I understand that there is increased exposure to estrogen, but what is the meaning of unopposed?
It's proliferating continuously.
It's proliferating continuously. Who said that?
Aishwarya.
Aishwarya. Okay. Now, what does unopposed estrogen mean?
Unopposed estrogen means when there is an ovulatory cycle, there is when ovulation is not happening, there is no progesterone. So these glands are simply proliferating under the influence of estrogen. There is no progesterone to get them to undergo the differentiation.
According to you, unopposed estrogen occurs only in a cycling endometrium.
In corpus luteal defects also it can occur, ma'am.
Corpus luteal, in other words, what you're saying is it happens in a cycling endometrium, right?
Yes, ma'am.
Yeah. Okay. That's what Bhavna thinks. Mansi, what do you think about unopposed estrogen activity on the?
Unopposed estrogen activity is when the glands keep on proliferating in the presence of estrogen, but they do not differentiate. There's no progesterone. There is a lack of progesterone. That will.
Very good. So Mansi, that's true. But do you believe, like Aishwarya and I think Ananya or Bhavna rather, do you believe that this happens only in a cycling endometrium?
Ma'am, it can occur in post-menopausal women as well.
Okay. So Mansi, you'd like to explain how it might occur in a post-menopausal endometrium?
Ma'am, usually post-menopausal women are put on estrogen therapy.
Okay. So you need exogenous estrogen therapy, like what is called hormone replacement therapy or HRT. Yes, Mansi?
Yes.
Okay. Ria, what do you think? Mansi thinks that you need exogenous estrogen. Bhavna thinks that you only get unopposed estrogen in a cycling endometrium. I think that was Aishwarya as well who thought the same thing. Okay, and both of them happen to be from PGI. All right, good. Ruta, what do you think?
If there are estrogen secreting tumors or something like that, even then it can happen.
Right.
Like an hyperestrogenism.
So you're giving me causes, right? Yeah, so somebody says that it is anovulatory, that's a cause. Somebody says it's HRT, that's a cause. Somebody's telling me that it is tumors, and that's a cause. What is the actual meaning of unopposed estrogen activity? What should be opposing estrogen and is not opposing it now? I think. Sorry, yes.
There's an imbalance.
Pituitary axis.
Pituitary.
The HPO.
The what? Sorry.
The hypothalamic pituitary. They usually have. Yeah.
That's what Mansi thinks. Oh, okay. Ruta.
Gonadotropins.
So now we've got another cause. Gonadotrophins. What actually is the meaning of unopposed estrogen? It means
There is an imbalance between the estrogen and the progesterone. There's excess
there's no
estrogen.
question of imbalance. There is no progesterone. So in the system, wherever the estrogen is coming from, all right, in the normal cycle, yes, progesterone follows estrogen. Okay, and in normal cycles, if you have an anovulatory cycle, that's one of the causes where you don't get progesterone. Okay, but what about postmenopausally? Yeah, you've given me some causes, but where, without exogenous or tumors, can you get estrogen? Can you get estrogen in the system after menopause? And you will not get progesterone because there are no follicles, for God's sake. So where is the estrogen coming from in menopausal women?
Obesity.
Obesity, very good, yes. And what? Well, there are lots of endocrine dysfunctions, no? You can get, obesity is the main cause of this kind of estrogen, right? So you must, when we say unopposed action of estrogen or unopposed estrogen is a term that we should all learn how to use, okay? And I think quite often that when you say things like disordered proliferation and this and that, yeah, what you are seeing actually is the effect of unopposed estrogen activity. And what it tells a gynecologist immediately, or whoever is reading that report, that you have a system in which there is estrogen and there has been no progesterone for a very long time, and this patient is maybe cycling, may not be cycling, okay? But there has been no progesterone. And it's very important for a gynecologist to know that you have got a system in which there is unopposed estrogen. Yeah, so why am I saying all this? And why did I spend this time in telling you about the effects of estrogen and progesterone on the endometrium? Because you can best understand when you look at the endometrium what is happening to this, in the hormonal milieu that is circulating around this in that particular patient. And it makes life so much easier for you to understand instead of fighting for, terms. Shall I use this term? Shall I use that term? When it is so easy to. So here you have the atypical hyperplasia or EIN, and the first one you can call it disordered proliferation, but all of these, or both of these, are sometimes people call these things simple hyperplasia with cystic change or whatever, call it anything you want, so long as your gynecologist understands it. But the important thing is to tell them that there is only estrogen in the system and there is no progesterone. Okay, now I'll give you some examples. All right, now here is a patient, she's 51 years old, average height and weight, non-diabetic, non-hypertensive. The LMP was 45 days ago and she's had intermittent spotting, and the USG shows a 9 millimeter thick endometrium. All right, now let's ask somebody. Bhavna,
Yes, ma'am.
now tell me, what do you think this whole story is?
Ma'am, USG there is increased in thickness of the endometrium,
Yes, wonderful.
and the patient is 51-year-old and the last menstrual period was 45 days ago, so perimenopausal state. The patient is having intermittent spotting also.
Right.
With average height and weight, so BMI supposed to be normal, non-diabetic and non-hypertensive patient.
Very good. Yes, Bhavna.
So in this first slide,
They're
let's
all
say
they're all from her, so I mean, you can just say, how is it? What will you say when you have to tell the gynecologist what is going on? Obviously, they found this thick endometrium, and she's 51, and there is every chance that this woman might have some, or is incubating some malignancy, right? That's why they did this. And as
yes, ma'am.
Dr. Bhupesh said, this is one of the indications for doing an endometrial curettage. So what will you say? Come on, Bhavna, it's not difficult.
Yes, ma'am.
See, if you're able to describe what you're seeing, and you don't have to go into great details. I see these kind of glands and that kind of glands. What do you see?
Yes, ma'am. In this, you can see there are these glands which are dilated, and the stroma also, and here also these irregularly spaced, these dilated and tubular glands also, and here also there is some increase in the glands with back-to-back glands with the branching also in this slide, and here they are cystically dilated also.
I know you're describing all this, no? But everybody needs to describe. But what is the message you're getting from these pictures? Okay,
This
what
looks
is the
like
message? Number one, number two, number three. There are just 3 or 4 messages that you're getting from these pictures. And what are they? Number one,
there is maintained.
this is a proliferative endometrium. Yes or no? It's
Yes,
a
ma'am. This is
proliferative phase.
proliferative.
It is
endometrium.
proliferating. Yes, right. You may wish to call it proliferative phase, but it's not a normal proliferative phase.
Yes, ma'am.
Very good. So why do we say it is proliferative?
Ma'am, because of this nuclear stratification in these glands taken.
There is no high power. Yeah. But
yes,
there
ma'am.
are some things that are missing, no, which you would have seen if it was a secretory phase, but this woman is still cycling. Okay, you're not seeing any spiral arterioles. You're not seeing.
There is no.
Yeah, and there's certainly no
activization.
secretions and other things. So you assume, yes, that this is proliferative. This endometrium is proliferating, except that this is
Yes.
not the normal proliferative phase endometrium that you expect to see in the usual reproductive years. You agree, Bhavna?
Yes, ma'am.
Very good. So it is proliferative. Okay, next. What from this, all these pictures that you see, we've made out that it is abnormal. So it is an abnormal or atypical proliferation. It is architecturally atypical, right? I don't think you see some bizarre looking cells.
No, ma'am. No, ma'am.
Oh, so it is
No.
architecturally atypical.
Architecturally atypical.
Very good. So we
Nuclear
covered that. So there is atypical proliferation. Agreed?
Yes, ma'am.
Yes. Now, do you see anything else that you might want to notice over here? Do you see something here in the right-hand corner in this funny-looking gland? You can see. Let me see if I can annotate it. Yeah, in this. Do you see anything here? It's this is the high part of this.
Yes, ma'am.
What do you see over there? Even at this far, you can see it.
This gland is cystically dilated and showing branching and some sort of.
You see a metaplasia, no?
Yes, ma'am. Sort of cilia. I feel like it is there.
Yeah, they're just very prominent snouts.
Yes,
Apocrine
So there is a sort of metaplasia to this endometrium. Sometimes you see cilia, sometimes you see other types of metaplasia. Even squamous metaplasia in this endometrium. Okay, so we are seeing an atypical endometrial proliferation, but here the third thing that you can say is that there is no back-to-back glands, right? So there is no crowding of the
Yes.
glands. There is sufficient endometrial stroma. So what did we notice? That number one, this was proliferative. Number two, what was the second thing that we?
Architectural ATPI is there.
Architectural atypia, but
And
there is no
metaplasia.
crowding. Okay, yeah, there's no metaplasia and there's no crowding. So what does it tell you about this endometrium? What is happening with regard to the effects of the 2 major hormones that act on this endometrium? What?
Disordered proliferation.
Sorry? It's disordered proliferation. That's Ananya. Yeah, but what does it tell you? That there is estrogen in the system, otherwise you can't get proliferation. Do you agree?
Yes.
All of you agree that without estrogen, unless there is cancer of a different kind, which is serous or clear cell or something, if you get proliferation in the endometrium, it is because there is estrogen in the system. Do you agree with that? Excellent. So there is estrogen in the system. And number 2, there is no progesterone. And there's never been progesterone, right? So this is essentially atypical proliferation, unopposed due to unopposed estrogen activity. And this is what we expect to find in perimenopausal years where ovulation is very uncertain. Okay, the eggs are dying. There is, imbalance in your FSH and the whole system, which was imbalanced when it started at menarche, is becoming imbalanced now towards menopause. Okay, so how will we report this now? Yeah. Oh, sorry, what happened? I didn't. There is, but anyway, this is an atypical proliferating endometrium due to unopposed estrogen, and you want to call it disordered proliferation, it's fine. But the important thing is that you should recognize that this is an estrogen effect, that there is no progesterone, there is unopposed estrogen in the system, and there is some architectural, sort of atypical. Okay, but there's no back-to-back. There is some metaplasia as well, and this is what you expect. Okay, now here is another one. Now who wants to take this? Mansi, you're next in my line. 48-year-old female with recent heavy periods, and there was a hysterectomy without prior DNC.
Ma'am,
Now this is a hysterectomy. Now this is not a great problem. Come on, Mansi.
ma'am, in the slide, we can
Take
see
the first thing on the left-hand side because the others are all just hyper views of that. So tell me.
ma'am, in the first slides, we can see that there are large cystic glands. They are dilated.
Yes, Mansi, I can see that. That's all you see. Mansi,
Uh,
can anybody help Mansi? I can see three things. Can anybody else see three things? Mansi, can you see three things? Or three different areas?
I can see the basal, the stratum basalis, which is
So
present,
these are this.
and muscular layers, muscle can also be seen. Myometrium
You know
is
what I
seen.
see? I see one thing here. Yes, of course, there's a muscle. And you can see that. Let me take another color. All right. Can you see here that there is the endometrial myometrial junction? Yes. Mansi, can you see?
Yes, ma'am.
There is the endometrial myometrial junction. Okay. It's there. So, and I see three zones because everything superficial to that is the endometrium, right? Very good. So in this zone where I showed you this zone over here, yeah, where you can see where I have outlined it. What do you see here, Mansi? Does it look like this zone? Sorry. Does it look like this zone? You only describe this zone, but I see zone number 1. Okay, this is zone number 1. This is zone number 2, and I see zone number 3. Come on, Mansi. So what do you see in zone number 1, zone number 2, and zone number 3?
And in zone number 1, there are few glands that are smaller in size, look atrophic. In the second zone, there are the glands have dilated, and in the third zone, they are in back-to-back arrangement.
Mansi, see how much you were able to see? But you went and described just one thing when you looked at this endometrium. So Mansi, that is a lot, and you can now let us see. You have got one zone that looks perfectly normal. Yes, that is zone number 1. Then you have zone number 2, which is showing you cysts. But it doesn't seem to be very, apart from the cystic change, there is no cytological atypia or anything. Okay, and you can see a higher power of it to the right. You can see that, and then comes zone number 3. And zone number 3, there's a high power view on the right hand side top. And that has got back-to-back, or at least very little stroma between the cells. Okay, and if you look at zone number 1, which I have shown you at high power over here, notice that you can see the endometrial lining on top. So this is something like an endometrium that is almost atrophic. I don't think that this woman is going to cycle for very much longer. She's had recent heavy periods, and we don't know whether this hysterectomy was done, because she was bleeding, and they so you may not, they did it to stop her bleeding, and you may not see a lot of the endometrium on top, the functionalis, because she may have bled part of that endometrium. But nonetheless, you're seeing benign looking endometrium, bottom left hand corner, which corresponds to zone number 1. Okay, and you can see what that looks like. That's the high power of that. You can see cells in mitosis. Okay, so you have got, Mansi, an estrogenized endometrium. There is estrogen in the system because it is produced. There is a proliferative phase. There is a cystic phase over here, which we call simple hyperplasia. Once upon a time, you need not use the term cystic glandular or whatever you want, but this is a cystic proliferation in this endometrium. And then what has happened? Okay, there is back-to-back glands. So you can see that there is. You see that there is atypical hyperplasia. You might want to call it endometrial intraepithelial neoplasia. I tend to use these terms interchangeably. Yeah, simple hyperplasia with cysts and a proliferative endometrium. And if you want to draw the estrogen, the response of these different parts of the endometrium, here, zones that you are seeing to estrogen, you can see that this has responded to estrogen in its normal fashion. This is showing hyperplasia, and this is showing atypical hyperplasia and EIN. So Mansi, you can see a transition, right? So can you just tell me, Mansi, quickly, how come in the same endometrium with the same amount of estrogen, you have 3 zones? Quickly, Mansi. Or anybody else can tell. Yes, Riya. Why? There's the same amount of estrogen, right?
Yes, ma'am.
You think that there is a specific amount of estrogen that only touched this and another one there. So why did that happen? Yeah, Riya, or Mansi, or anybody who'd like to answer the question. Why? What is this got to do?
The receptor.
And
Yes?
the amount of receptors that are present along the
Yeah, it's the amount of its receptor recruitment. Okay, the very fact that you haven't got something that is the same right throughout this uterine endometrium means that receptor recruitment is different in different parts of the endometrium. And remember, when you get to any target organ, why do you get nodularity in the female breast? Why do you get nodules in the thyroid gland? When you have the same levels of TSH, same levels of estrogen or progesterone during the cycling for the breast, and yet you get nodularity. Why? Obviously, it is all about, yes, what Mansi?
The receptor.
It's about?
The hormone.
Yes, receptor recruitment, and it is about, in the thyroid in particular, it is about, again, TSH receptor recruitment, in which you can get hyperinvolution as well as hypoplasia. Okay, so that is in any endocrine organ, and you're seeing an example of it over here. All right, now, as far as classification is concerned, I'm not going into this, how you classify and all this, because that's but I think that the WHO terminology, which was proposed in the 4th edition and now has been kept, in the 3rd edition and is kept the same in the 4th edition, is, that was in 2018, is hyperplasia without atypia, and that was what Dr. Bhupesh also said. And there is atypical hyperplasia, stroke endometrioid intraepithelial neoplasia, and it's endometrioid because this is not just any old endometrial because the progression is towards an endometrioid adenocarcinoma. So the synonyms, if you want to use them, any type of hyperplasia, simple, complex, without atypia. And here is any hyperplasia with atypia, or you can use the synonym EIN. Now, the important thing is that there are different genetic changes that accompany these different morphologies. There are very low levels of somatic mutation in the hyperplasia without atypia. Okay? And it may be in scattered glands. Now, how did they find that out? Because they did microscopic targeting of these things, or by immunohistochemistry. The genetic changes that are seen in EIN or atypical hyperplasia, whichever word you want to use, are typical for endometrioid carcinoma. And those are microsatellite instability, PAX2, PTEN, KRAS, or beta-catenin. These abnormalities are there, and as a result of which, you can imagine it is like a dysplasia that is occurring in the endometrium. So almost 25% of these patients will have coexisting carcinoma. This can vary from 25 to 59%, or may progress to carcinoma. Of course, the relative risk for progression is very low for hyperplasia without atypia and is much higher for the other one. So as long as you know this, that you can use atypical hyperplasia. I don't like to use the word hyperplasia in the same breath as saying neoplasia, okay? Because I think we should try and make the distinction. So I use the term atypical endometrial proliferation. You can then use any other term that you wish, provided that you actually qualify what it is that you are saying. All right. Now here we have an endometrium. Who would like to take this? Aishwarya, you want to take this? Can you read the history? Yes, Aishwarya? Are you there, or she's dropped out? Never mind. Ruta, are you there, Ruta?
Yes, ma'am.
Right. Can you read the history on top?
32-year-old woman, married
Yes.
for 2 years, being investigated for infertility. USG showed a thickened endometrium, and LMP was 40 days prior to DNC.
Okay. So now come on. We've done this, so you shouldn't have a problem. Come on, Ruta. What can you say about
Okay.
this? You know how we're going to approach it, right? So what do we want to say? We want to know, is there estrogen in the system? Is that being followed by progesterone in the system? Is there proliferation as the result of that estrogen? It has to be unopposed estrogen. And then we want to say whether there is atypia or there's not. So come on now. Is there estrogen in the system?
Ma'am, the glands are like, we can see some outpouchings and branchings.
Okay. Yes, I can see that.
On lobe.
You know, we waste time when we are going there. I can see outpouchings and so on. Just tell me the answer to these 4 things. Right? Is there estrogen in the system?
Yes.
You know what I mean by system, Ruta?
Yes, ma'am.
Meaning?
Means unopposed estrogen in the body in general.
Yeah, so the system is the body, right? So do you think there's estrogen in this system, or has been in the system? Yes or no?
Yes, ma'am, because I can see mitosis.
You can see mitosis. Excellent. So there is estrogen in the system. Is there progesterone in the system? Do you see differentiation? Do you see proliferation? Do you see differentiation?
No. Yes, ma'am. I can see differentiation also. Tubular glands, I can see.
Tubular glands. Now, how do you know that there is progesterone in the system? By looking at the shape of the glands?
Vacuolations, supranuclear vacuolations and all.
Oh dear. That's the way that we know that there is progesterone in the system. Ruta?
Yes. So I cannot see them.
How
So-
do you know? You can't see them. So you look at what? You look at the stroma and you look to see whether there's decidualization, or anyway, the stroma is looking less compact. That's number 1. Number 2, are there spiral arterioles? No. Is there any? No, there isn't. So this means that there is no progesterone in the system. We know that there's estrogen in the system, but there's no progesterone. So then what is the conclusion that we draw? That there is unopposed estrogen. Excellent. So there is unopposed estrogen in this lady's system. Okay. And what has that unopposed estrogen done to this endometrium? Come on, Ruta. That's easy. What is there on the left-hand side of the screen, and what is on the right-hand side of the screen?
Hyperplasia. Simple gland.
So on
So
the
I
left-hand
cannot
side,
see-
what do you see?
I cannot see atypia, so it is atypia is
It's not there.
I
So
think
this is
it's
hyperplasia,
unlikely.
right? You might call it disordered
Yes.
proliferation, simple hyperplasia, call it anything, but it's hyperplasia without atypia, right?
yes, ma'am.
Yes. Now what's on the right-hand side of the screen?
Okay,
now
so
you
this
can
is
see. What do you see? You see glands?
yes, ma'am.
Very good. Very good. And do you see good stroma between the glands?
No,
No. So see, back to back
Okay.
glands. Yes.
back to that.
Crowding. Here on the left-hand side, there is no crowding. There is enough stroma. Only that stroma does not show you progestational effects. Okay. The glands are showing you estrogen effects because they're disordered, they're branching, etc. Okay. And on the right-hand side, you see crowding. So what is that crowding and this proliferation? What should you call it? That was
Simple,
typical or hyperplasia without atypia. So what is this, Ruta?
simple glandular hyperplasia.
So now you think this is simple on the right-hand side when you get crowding together. Mansi, you want to help her?
On the left, on the right side is atypical endometrial proliferation.
Yes, so it is atypical hyperplasia, also called endometrial
Intraepithelial neoplasia.
Now, come on now, Ruta. Was that difficult? No. So in this endometrium, and Ruta, please read the history again. What is it?
32-year-old woman, married for 2 years, being investigated for
old is this
infertility.
How old?
32-year-old.
32. Married for 2 years. Has infertility. Okay. And now she's bleeding. She's bleeding. She's got prolonged bleeding, etc. So what will you think is the problem with this patient? What is the problem with this patient? Ruta? No? Ria? Okay, let's ask the third. Yes, please, Ria.
Yes, ma'am. Ma'am, there is unopposed estrogenic stimulation.
Excellent. There is unopposed estrogen. Now, why is there unopposed estrogen? So now you've got the idea that this is unopposed. This is an endometrium showing the effects of unopposed estrogen. So there is a lot of estrogen in the system, but there is no progesterone. Very good. So now we have to figure out in this young woman what is causing unopposed estrogen effects. So what do you think? Why should there be unopposed estrogen? She's young, she's 32, she should be having, ovulation, there should be progesterone. So, Priya,
Mobility.
she's having ovulation. But why? It just happens to be one anovulatory cycle that will produce this. What do you think? It has to be long periods of estrogen without any progesterone. Long, otherwise you can't get this. Okay, so anybody, Bhavna?
Can be because of
PCOS,
ma'am.
PCOS.
P, what? Yes, somebody said the P word.
PCOS. ma'am.
Yes, this is what happens in PCOS. You often have lots of follicles that are, there's no ovulation because the follicles are not releasing the eggs. They don't have, the right kind of hormonal milieu to actually have ovulation. This is part of this, what we call the metabolic syndrome. There is insulin resistance in these patients. They have high levels, the stoma is producing high levels of androstenedione. It's a huge metabolic syndrome, whatever it is. But there is PCOS, okay? And the real problem with these patients is that this will keep on happening unless the metabolic syndrome is addressed. You can temporarily get rid of this by giving progesterone, but that's only a temporary issue. It's only acting on the estrogen, but the entire metabolic syndrome, the lack of ovulation, etc., requires a completely different way of dealing with this. Okay, you've got to use GnRH and several other remedies for this thing. Now, Ruta, did you get the idea that when you see this, you know instinctively that this is unopposed? This endometrium has been acted on by unopposed estrogen, and I hope everybody gets this picture. Okay, there is no simple hyperplasia on the right hand side, Ruta. Okay. All right.
Yes, ma'am.
So this is an atypical endometrial proliferation driven by unopposed estrogen stimulation. It is indistinguishable from AHEIN, and if we don't have the myometrium, which we are not likely to get because this is you can't do a TCR, it could also be a well-differentiated endometrial carcinoma. There may be, because you can't tell the difference between EIM and WEC in most of these curatives. Okay? And then you say that many such proliferations in young women are reversible by appropriate hormonal manipulation, and you ask whether the patient has a PCOS. Now here, who's going to read this history? Let's see. Anybody wants to volunteer?
40-year female.
Right. Who's that?
Bhavna.
Bhavna, good.
40-year-old female, late marriage, a long history of irregular periods with infrequent bouts of heavy bleeding, never sought a gynecological opinion till desirous of conception. USG showed polycystic ovaries, thick endometrium, no myometrial involvement.
Good. Now come on, Bhavna. Now this is not difficult, right?
Yes, ma'am. Here I can see there is in the first picture.
I just want what you are going to write, because describing this is fine. We will keep on saying, papillary, and it shows mitoses and tall columnar and all this. Okay, but what are you seeing?
There is, ma'am, proliferation of the glands in this. I can see with increased gland and there is increased gland and stromal ratio, and here I can see some papillary enfoldings also. So
Exactly.
I feel there is hyperplasia, but it is
There is more than hyperplasia. No, where is the glandular? Where is the stoma?
stoma is very scant in this, ma'am.
Okay, and there is papillation.
Yes, ma'am. Papillary projections are there within this.
So, and there is metaplasia as well. You can see, right?
Yes, ma'am. Here
Yes,
I feel there is metaplasia also, mucinous.
So, but these glands are not round like you saw in the others, nor are they branched in the usual
More
kind.
of columnar kind of.
Exactly. Yes.
I can see, and there I feel some cytoplasmic this mucin. Some cilia I can see over the cytoplasm.
Snouts, no? I think
Not apical snouts I can see.
Okay. Yeah. All right. So what would you have called this? Now I'll just ask you. If this was a 60-year-old woman, what would you call it?
60-year female, ma'am. Then
Suppose this woman was 60. Now she's not 60. She's 40 or something. If she was 60, what would you call it? Bhavna? If this lady was 60 years old and this was her endometrium, what would you call it?
atypical hyperplasia, ma'am.
In a 60-year-old woman, you're going to call it atypical hyperplasia. Why? Why?
Ma'am, it can be endometrial carcinoma also.
Can be. You think you were going to say that this is not endometrial carcinoma? Of course, it looks like endometrial carcinoma.
Endometrial carcinoma.
I don't think that we would wait to call this atypical hyperplasia, would we? No.
No.
But now this woman is not 60, she's 40. And this is a cycling endometrium. Now, in the sense that she's got irregular periods with infrequent bouts of heavy bleeding, etc. So this is a cycling endometrium. It's very hard to get an endometrial carcinoma in a cycling endometrium, right?